So we are going to look at triangle similarity. We are officially in November. So we haven't even had Thanksgiving yet. Okay. But this is our last unit for this section. Okay, we are going to spend a few days on it to make sure we have it down because we're doing really well with proportions. And so if we could do really well on this next part, then I'm confident that we'll do well on our next test. Okay, I want it to be just as good as the similarity test that we took, a couple weeks ago now? All right. What are the pieces of information that we need to prove that triangles are similar? What have we been using? What did we have to show? Okay, scale factor, but let's, I want to be a little bit more specific. Yes, it's scale factor, but what specifically? There were two things I gave you that we had to show to prove that triangles were similar. Something about their angles and sides. What about their angles? Let's start there. All angles have to be congruent. Okay, and you said scale factor, so it's something with their sides. What about their sides? Starts with a P. Nope. Proportional. Sides have to be proportional. Okay, and really this is for any figure. It's not necessarily for just triangles. Okay, if we're proving any figure is similar, we're proving that all the angles are congruent and all the sides are proportional. And you even said that this means we're looking at their scale factor. Okay, that's how we've kind of spent really the last month when we're showing figures are similar. We're going to look at specifically today triangles. Okay, now in IM1, you proved that triangles were congruent, and you had a lot of different ways to prove triangles were congruent. Does anyone remember any of those? Side, side, side.
Angle, side, angle.
Angle, side, angle. Side, angle, side. Hypotenuse, leg. Remember all those? Okay. Similarity is nicer because there are only 3 options. Okay. So there are 3 ways to prove triangles are similar. So this only works for triangles. If I asked you to prove if squares were similar, then you'd have to do all the angles are congruent and all the sides are proportional. If it's a triangle, we can take a shortcut. Okay. So the first one is angle, angle. And who remembers that theorem now that I told you about that says if 2 angles in one triangle are congruent to 2 angles in another triangle, then the third angles have to be congruent? Does anyone remember that name? The what? The third angles theorem. Okay, so if 2 of the angles are congruent, we know those third angles have to be congruent. So that's the first one. The second way to prove triangles are similar is by side, side, side. And the third way and last way is by side, angle, side. Now, if you look at each of those, it takes different information, right? The first one, you just need to know about the angles. The second one, you need to know about all the sides. The third one, you have a mixture. If you know those 3 and we go through the problems, it will help your processing. And I'll show you what I mean. Now, before we actually look at triangles, and I know we've already reviewed this, but I want to look at it again from IM1. If you have 2 parallel lines cut by a transversal, we remember the angle pairs that are created. maybe? What type of angle pairs are created?
Interior.
Okay, so let's start with alternate interior.
Yeah.
And we abbreviate that as AIA. How many sets of alternate interior angles do we have?
2. 4. 7. 8.
Sets. So alternate interior, and then on the opposite side, right? So here and here. So we have 2 sets of alternate interior angles. Okay, this is going to be important for us as we are proving, so that's why we're going back over it. What's another type?
Alternate exterior.
Alternate exterior angles. And how many sets of alternate exterior angles are there? 2. So alternate exterior angle. What other type of angles do we have? Corresponding angles, okay. How many sets of corresponding angles are there? Where are the corresponding angles?
The line that makes 20.
So if I say that this is a corresponding angle, my happy face, where would I put the other happy face?
Across the alternate interior angle.
Here?
No. Sure.
How about here? Corresponding angles, remember, are on the same side of the transversal and on the same side of their parallel line. So here's my transversal, they're both to the right, and then they're both on the bottom of their corresponding line. So how many sets do I have? 4. So here, here, I'm running out of shapes. Here, the triangles, and the question marks. I have 4 sets of corresponding angles. Now, you don't need to draw all these in. I'm just going through them. What else do we have? Huh? Vertical angles. These ones we will probably use the most as we are going through this. So you need to know vertical angles. Where are vertical angles located? At an angle, right? They're what we call our kissing angles. So, like here, I'll put a heart. So here, and then here. How many sets of vertical angles are there? How many? 4. 1, 2, 3, 4. These are the ones that face each other. These are our kissing angles. And again, these are the most important as we go through. You need to know these. Okay, so you need to know where vertical angles are located. There's one other type of angle that let's review real quick. Does anyone remember the last one? Linear pair. Sure. I'm not going to write that one down. But yes, linear pair. And then I called it something different at the beginning of the year than you remember it. Anyone remember which that one was? I called it same side interior. You called it consecutive interior. Same thing. And then same side interior, obviously they're on the same side on the inside of those lines. So these two angles here. How many sets of same side interior are there? 2. Okay. But again, if I can iterate anything, you are going to use vertical angles the most. You need to know vertical angles. Could we potentially see the other ones? Yes. Will we definitely see vertical? Absolutely. Okay. All right, so let's get to proving. So we are going to explain why the triangles are similar. And write a similarity statement. So we're going to explain why the triangles are similar and write a similarity statement. So you get to draw today. Ready to draw some triangles? As ready as you're going to be? I'm going to give you a second, and then we're going to process through the best way to solve these. Okay? This is always the hardest part of this unit, and we're going to spend a few days going through this. So, if we are proving triangles are similar, we have how many options? 3, right? You have angle, angle, side, 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 or side, angle, side. That's it. Now, when I look at that picture, I want to ask myself, do I know information about sides or angles or both? Yes, I do, is what I heard. Okay. Do you know, let's start with, do you know any information about sides? Because when we're proving sides, we're still showing that they're proportional. Do we know any information about side lengths? Okay, we know they're parallel, but does that tell me that the sides, what the value of the sides are? No. I know nothing about the sides, which means I can't use which of my my 3 ways. Side, 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 or side, angle, side. I know nothing about sides. So what's my only option? Angle, angle. Okay, so my only possible option is angle, angle. So what I want you to do is once you determine what that option is, you're going to write it out. And then we're going to start going through and filling it in. If we can fill in all the information, we can show that they're similar to each other. If we can't fill in the information, then they're not similar. Okay, so we need to find angles that are congruent.
Ooh, I know one.
You know one.
Yeah.
Okay, which one?
Because my math teacher said that the 2 triangles were going to meet, that's where they're congruent.
Okay, so these 2 angles here
Smart.
are congruent. I agree with that. Can someone tell me why they're congruent? They're vertical angles. Everyone okay with that?
Yeah.
Those 2 angles are vertical angles, which makes them congruent. Now, we actually have to write this out, so this is the fun part. If I just said angle Q, for instance, would you know what angle I'm talking about? No, because technically there's 4 angle Qs. Right? Well, because there's some here. Like, I mean, they're not inside the triangle, but there's another angle there. Okay? So I need to name it a little bit better. Do you remember from IM1 how to name an angle other than with one letter? PQT. I will take angle PQT. So angle PQT. So you name it with 3 letters, with your middle letter being where that angle actually is. So angle PQT is going to be congruent to
RQS.
we're just throwing out letters. Okay, so it's either SQR or RQS. Everyone agree with that?
Yeah.
Okay, let's pause for a second, and we'll fill it in, and I'll show you why we're going to pause. Do you know any other angles that are congruent? No? Okay. Do you know any information, and someone already mentioned it, about these 2 triangles? These 2 have parallel sides, right? Well, do you think I gave you all of this information for nothing? So if you have 2 parallel sides cut by a transversal, they're alternate interior angles. What 2 angles are alternate interior angles? P and R. And S and T, absolutely. But we only need 1, right? So angle P is congruent to angle R because they are alternate interior angles. So now let's go back up to my vertical angles. How would I write it? Would it be SQR or RQS? RQS because P and R are congruent, and that's how you wrote the first one. So angle RQS because they are vertical angles. You could say T and S are congruent. That would work too. Okay, but I already have my 2 pieces of information. I've proved that they're congruent by angle. The last step is to write a similarity statement. So I will always give you the first part of that statement. So I'm going to tell you triangle TQP, and you're going to fill in the other part. So what triangle is TQP similar to? SQR. Good. So this part you're always going to fill in. And then you're always going to fill in up here. If that was a little confusing or that process was like your brain's like, huh? We're going to spend like 3 days on this. I'm going to make sure you have it. Okay? But what I really want you to focus on as you go through these is what information do I know right off the bat? Do I know sides or angles? And determine which one of the 3 you're doing. At that point, it's a matter of filling information in. Okay? All right. Can we try another one? Sure. I like a sure better than a no. So, here we go. How many triangles does everyone see? 2. Everyone sees 2, the small and the big? Okay. Now I want you to take a second and talk with your group and figure out which one of the 3 ways you're going to prove. So what information do you know? Okay, so talk with your group for the next 30 seconds, and I'm going to randomly call in a group, and I want to hear what your thought is. I'm actually going to go to each group, and all I want you to tell me right now is which one of the 3 your group is choosing. So either angle, angle, side, 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 angle, side. Okay? So, hold on. I want to write it down so I know who said what. Okay, group A. What are you choosing? Which one of the 3?
You can choose angle, angle.
You're choosing angle, angle. Okay, group B, what are you choosing? Just give me one. Which one do you think is going to work?
I'm doing
Side angle, side.
Side, angle, side. Okay? Group C, angle, angle. Group D,
side angle side.
side, angle, side. Group E,
Side angle, side.
Group F,
Side angle, side.
Group G,
Side side
Group H,
side. Side angle side.
and Group I.
Side angle, side.
Okay, so at least one group chose one of them, every one of them. So let's start with side, side, side. Group G, why did you choose side, side, side? Okay, you don't know any angles. Okay, can another group tell me why they eliminated side, side, side? Connor?
Because we don't have the information about the third, MN and KL.
You don't have information about all three sides, right? You're missing KL and MN. That eliminates side, side, side. Okay, so we're going to take out side, side, side. Group A or C, why did you choose angle, angle?
These are the same side interior.
Okay, do you know that they're same side interior angles? Let me ask you a different question. Do you know that KL and MN are parallel? No. Okay, so looking at that, I don't really know any information that I can see off the top of my head about angles, but I do know some information about sides, which makes side, angle, side the appropriate choice.
Oh yeah.
Okay? So, in order to use side, angle, side, we have to show that those sides are proportional. Now here you have to go big triangle to, or small triangle to big triangle. So let's start on this side. What is the length of the small triangle? 2. What is the length of the big triangle?
6.
The whole thing is 6. 4 is just a piece. So when you're doing similarity, it has to be the small triangle to the big triangle. So you were, if your triangle looks like this, you're going to have to add the whole thing together to get the big side length. Okay, what is that ratio reduced to? 1/3. Okay, let's do the second side because that one's easy to find. What's the small triangle on the second side? What's the large triangle? 9. And what is 3/9 reduced to? 1/3. Okay, so we showed that those sides are proportional. Now we have to find an angle that's congruent. Anyone see a congruent angle? Jay? Jay's correct. Angle J is congruent to what? To itself. If I take out this little triangle, doesn't the big triangle still have angle J? Like the small triangle has angle J, and if I took out that, the big triangle has angle J. Okay, they share that angle, meaning it's congruent to itself. Now think back to IM1. I know that's hard sometimes. Who remembers what property that is? What property says angle J can be congruent to itself? The what property? How about the reflexive property? You've never heard of the reflexive property? Okay. Well, now you've heard about it. The reflexive property says that angle J is congruent to itself. So if I tell you triangle LJK, what triangle is similar to LJK? So I gave you the small triangle. For the small triangle, I gave you LJK. What's similar to LJK? NJM. Okay. We're gonna do these pretty much until the end of the period at this point. I'm not gonna give you homework, and then we're gonna do it again tomorrow, okay? So I just wanted to keep you focused and make sure you just kind of keep processing with me, because this is the hardest unit. I have to flip pages. So remember, if you flip, it's still page 49. If you don't need to flip, don't. If yours is still fitting, that's fine. Okay. Let's look at another one. Let's look at this one. Okay. Okay, so let's look at this information. Can I eliminate anything from our three options? Angle, angle. I don't really know anything about angles. So then I have side angle side or side side side. Which one's probably the easiest to use? Side side side, because either I know enough about all the sides and or I could find those missing pieces. I will tell you, for this particular problem, you could also use side angle side. Okay, either one will work, but let's do side 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 since we haven't used it yet. Okay, so side side side. When you're proving, you will always write that down and you will fill in the information. This is what I'm looking for. Okay, so what sides do we want to start with? 8 and 24. Okay, so FG and BC. I'll take that. 8 over 24, because I did small to big, reduces to 1 over 3. Okay? Everyone okay with that? 8 and 24. What else can I do? 13 and... Okay, but so the small triangle is 13. What's the big triangle? 39. Remember, it's small to big, not the pieces here. It has to be small to big. 13 over 39 reduces to 1/3. Okay, so now I need to look at this side. What's my small triangle? How'd you get 11? Okay, So this piece here is 11, because 33 minus 22 gives me 11. That's my small triangle. What's my large triangle? 33, and that reduces to 1/3. Are my proportions all the same? Yes? Okay, so let's say triangle BDC. What triangle is BDC similar to? FDG, good. Now, I do want to take a second, and actually we're going to prove it with side angle side because I want to show you which sides and angles we have to use. So if I'm proving with side, angle, side, you actually have to set it up properly. You can't just use any of the 3 sides. It has to go in order. So let's start with our angle. What angle is congruent? D, right? Angle D is congruent to itself. So here's my angle. What side do you think I need to use now? If it has to be side, angle, and then a side. So which side do you think I need to use? DF and DB. Because here's a side. So this would be my 13 over 39, which reduces to 1/3. So I have a side, an angle, and I need the next side. Which one do I have to use? 11 and 33. Because it actually has to match up. So I can't use this one here because then I would have A, S, S, and that's a bad word, and you're not allowed to use that. Okay, so it has to go in order. So side, angle, side. So if there's a couple options, you need to make sure that it all lines up properly. Okay? I'm going to give you one, and I want you and your group to do it. Can we do that? Hi. All right, let's see. Why don't you try this one? So figure out which one of the 3 you're using. And then you'll fill in your similarity statement. Okay, so with your group, I want you to figure out which one of the 3 and then fill in your statement. You chose angle, angle. Someone give me which angles are congruent. Angle Q and angle A. I'll take that. Angle Q is congruent to angle A. I don't need to name it with 3 letters because there is only one angle Q for the triangle and one angle A. I mean, there's technically this, but that's not part of the smaller, the big triangle. Okay, so angle Q and angle A I'm okay with. And they're congruent because they both have the same measure, right? They're both 72 degrees. What else is congruent? Angle S is congruent to itself. Why? What property says they're both congruent? The reflexive property. Okay, so since we filled in all of that information, SRQ is going to be similar to what? SBA. Nice. Are we okay with that? Yeah? So I'm going to give you one problem. If you finish now, great. If not, it will be your one homework problem. Okay? Everyone should be drawing this. Oh, well, why didn't you say something?
We just did.
Yeah, this is a Y. Okay, so you're going to draw this. Shh, listen carefully. Shh. You're going to draw it. You're going to figure out which one of the 3 options, and if it's similar, you are going to fill in the similarity statement. Okay? So, you have not a whole lot of time. I'd like you to get it drawn, and this will be your 1 homework problem. That's not bad. Okay?